I'm going to show you how to find the centroid of an area. Part of the shape is a curved function. It's y equals x cubed. That's the function of that curve. The other two sides are flat, and it goes over to x equals 1 meter. Now, just at looking at this, you wouldn't necessarily know where the center is. It's not going to be at 1/2 meter. It's probably going to be a little bit further here because we're balancing. So the first thing we need is to find the x center and the y center later. The equation for the center of that area, or the centroid, in the x direction, it looks like this. Now we're taking the integral of this x tilde, and x tilde refers to the location of the center of a rectangle that we're going to draw on this area. Now I'm going to integrate this tiny rectangle from 0 to x equals 1 meter. I'm considering all possible rectangles that can be summed together in order to make the entire shape. Notice that the center of this rectangle, according to the origin, if I draw a position vector from the center, is about right there. That's going to come into play as we find this x tilde and later y tilde. But first, let's consider the area, dA, of this tiny rectangle. It has a width of dx and a height of y. I'm going to integrate over the x direction since I've got everything in terms of x. So I need to change this into its x function, which is x cubed times dx. The distance from my origin to the location of the rectangle in the x direction is simply x. I'm going to locate this rectangle at x, and I'm going to integrate x from 0 to 1 meter. Okay, and now I've got all the ingredients that need to go inside of this equation. Now you can see what I've done here is just put dA, all in terms of the x coordinate, that's my integration variable. I've put dA here and the x tilde here. So I've just substituted all of these things into that equation. Now I encourage you to pause the video and see if you can solve this integral, both integrals, and come up with the same number that I'm going to give you in a moment. Now, the question that is the right question to ask at this point for any physics problem is, does that make sense? Does 0.8 meters seem like the x center of this area? Well, it's between 0 and 1 meter, so that's a good step. It is also a little closer to 1 meter than it is to 0, so that seems reasonable as an answer to this problem. So now let's find the centroid in the y direction. Notice that the center of this rectangle, as measured from the origin, it goes over and up, but it only goes up half of the way through y. So our y tilde here is already different from the x tilde. It's y over 2. It goes halfway up the rectangle. And it turns out that way because we're integrating in the x direction. In other words, we're taking a vertical rectangle from here to here instead of a horizontal rectangle from here to here. That's why this one ends up being half and the other one is not. dA, we're still going to integrate in the x direction, so dA is still going to be y dx. Take a moment to think about why that is. I've got a width of dx and a vertical height of y. If I multiply those two things together, I simply get the area of the rectangle. So let's see, I still have to put this into x coordinates because even though I'm finding the y centroid, I'm still integrating in the x direction. Now there's a few things that we didn't cover here. Notice that I've got y over 2, so I need to put y in terms of x again. Now y itself, according to our curve here, is actually equal to x cubed. I'm going to write this y as x cubed because that's what it is in terms of our integration variable. Now what are the limits of integration? Well, remember that our limits of integration represent every place where we have area. And we have to go with our integration variable, which in this case is not y, it's x. and that goes from 0 to 1 meters again. Okay, this one's not quite as straightforward as the other one. You get a decimal that is 0.2. It's a positive number, so yes, that seems like a reasonable result for this problem. That's the centroid of an area.